speaker we have here has such an interesting background. It's Dr. Stanley Rosenschein. He's been involved in the AI space, robotics, and collaboration technology, both in an academic sense, and also he was the director of the AI Center at SRI International, which you all probably know in many capacities and in terms of all their inventions. The most recent we've heard, of course, was the Siri that was purchased by Apple. That's where the SNR and I come from. He's been affiliated with the Stanford University's Computer Science Department, the Center for Study of Language and Information, MediaX, and their medical school. And right now, he's the founder of BranchTime Technologies. And before that, he was the founder and CEO of two other tech startups, one in robotics and one in machine vision. One in robotics and machine vision, and the other in collaboration technology. And he holds a BA from Columbia and a PhD from University of Pennsylvania. So he has an incredible background in this space. And he's going to talk a bit about kind of from email to more open communication or, collaboration protocols. Dr. Stanley Rosenschein.
Thank you. So, yeah, no problem. What this talk shares in common with the previous one is the idea of putting some kind of buffer or filter between the sources and the uses of information. Except we'll be approaching that from a slightly more general perspective. And let me just start with this. Information overload. Many of the discussions centered around what an individual can do in a particular context when he's reacting to a situation. But I think to really get a handle on this problem, you need to think systemically. So let's pop up a couple of levels of abstraction and see where that takes us. Let's look at some of the other infrastructural provisions that we have in society. Think engineering and design of systems which are designed to deliver certain kinds of needed commodities, let's say, power, electricity, the ability to move through traffic, and so on. These are highly organized systems. The behaviors of individuals adapt to these systems, but they provide these services almost transparently without much thought in the moment. So when you go over to your tap, you find water. You want to find water someplace else in your house, good luck. You may have had to make some special arrangements to get it there, but you know you can get it reliably at the tap. So your behavior adapts to the efficiencies that are offered by these systems. And likewise with traffic engineers, they deal with an incredible number of variables when they design on-ramps and intersections and how many lanes and signals and signs and laws and this and that. But when you're driving down the street, you adapt to that and you adopt a set of conventions and a culture and an etiquette around what that infrastructure guides you to. An incredible amount of thought goes into those things and an incredible amount of modeling and analysis. Now, when we come to information systems, we all know and love the internet. But what the internet provides by way of services is essentially universal data connectivity. It's very, very low level of abstraction. On top of that are built many specialized apps. Email is the broadest level of infrastructure. Well, it's not the only example of its class, but it's an example of I won't say universal, but there are 2.4 billion email users out there. And what email systems are good at are delivering point messages reliably. Okay. A little bit of structure around that, but essentially once the email message is delivered, end of story. That's not a high enough level of abstraction to deal with the kinds of problems that we're talking about today. And I'm going to focus on a certain class of problems and abstractions and try to envision or imagine what kind of infrastructure might be more effective in delivering service as reliably as a power system, a traffic system, a water system, and so on. Now, let's focus a little bit more on humans and human needs. This is a crowd scene someplace. This is actually adapted from a cartoon. I can't remember if it was Far Side or New York. I looked for it for about half an hour last night, couldn't find it, so I just did my best at simulating it. But everybody's walking around with little thought bubbles over their heads, right? Everybody's pursuing their own plans, very, very complicated. And these plans interlock in various ways. And that's what they do. They create, share, and execute plans. That's what they do all day long. This is deliberate, conscious, intentional behavior. This is what we do most of the day. What we'd like to see from our infrastructure is social, cognitive, and behavioral support for that activity, right? Systemically, we'd like to see social, cognitive, and behavioral support. So let's meet Marcia. Who is Marcia? she's a worker, it's true, but we're not focusing so much on her life in the enterprise or wherever it is that she works. We're focusing on her life in general. Her life in general is that she has many people that she cares about, and she cares about many of their needs. And she responds to situations that arise around her. She's got 2 kids. She's got a husband. Her husband's away on a business trip. He dumped a bunch of stuff in her lap. She's aware of what he's doing on his business trip, but she's also got to follow up on all the things that he left behind. She's got her kids. One of them's applying for college, perhaps. Maybe one of them is, I guess nobody's applying for college in this example, unless Annie's a prodigy. One of them's got a science fair project. What does that mean? Well, the carpool person better bring the van because they have to get the science fair project to the school, and it's not going to fit if they bring. So there are lots of little details that unfold as she copes with these situations around her. Okay? I bolded one about her mom needing help with the gardener because we'll get to that in a second. There's her mom. Okay, so if you look at her social network, she has these concentric circles of social relationships with people. She has her primary relationships in her family, her nuclear family, her mom, and so on. And then she has circles around there. And each of these gives rise to situations that she needs to adapt to. But by the same token, they also provide individuals who are resources to her. They have information, they have certain actions that they can perform, and so on. And the truth of the matter is, if you take the whole human network and pick it up from any point, you'll see the same concentric circles. So we have this huge interlocking social network into which dynamic activities pop up. We're going to need to get into the microstructure of that a little bit in order to understand how to design a support technology. So let's take it step by step. Okay? First thing to notice is that those activities straddled different areas in which Marcia is involved, and in those areas there may actually be professional service providers. So for example, for health, there may be medical providers. Medical providers work in institutions that have legacy software systems that are highly structured and organized around delivering some certain kinds of services. But they're not necessarily organized to insert themselves into the attention stream of the individuals in their constituencies who lie outside their institutions. There is no infrastructure for that. So they resort to phone calls, emails, voicemails, and if they can get somebody to go and sign up on their website or download their app, when they're competing with all the other clutter that's out there and all the other websites and the 14 different people who are asking them to do the same thing, then they try to get them to do a little bit more structured activity. But it's not universal. There's no universal infrastructure there like our water system or the traffic system, etc. Okay. So let's take a look at a kind of a little, very small example and work out from that. Whoops, what did I do? Okay. Mom's yard is a mess. The city sent a notice. What is Marcia going to do about that? Okay. This is actually adapted from a talk that I gave with a colleague. We're working together on some more specialized tools for cognitively impaired individuals who need more close air support over the course of the day, more of a GPS for daily activity. But this was a handoff between that person and Marcia, who of course has a lot of other things on her plate. So how does she cope with this? Well, she goes through the life cycle of an intention. Namely, she observes a situation. What I didn't show here is how she deliberates and considers all the options, like ignore the notice, get her brother-in-law to do it, all the other things that she considered but rejected. Eventually, she settled on a commitment, and she intends to clean the yard. That needs to be unpacked, okay? What do I do first? What do I do second? Eventually, she gets down to the leaves of that plant tree, and those leaves represent particular actions. And those are actions that she can actually do, hoe, rake, plant, whatever she does. And those cause certain effects in the environment. Outcome is good, great, okay? So that's the life cycle of an intention. The thing I want to focus on is that it's not just the to-dos that we normally think of. To-dos are things that are just reminders for actions that you can take usually at an instant, right? There are lots of micro-cognitive steps here. There are decision-making steps, such as unpacking the plan and creating a subnode of that plan. Those may happen incrementally. The alternation between planning and action, these are things which AI people study all the time because they try to design robots to do this, or they try to design software agents to do this. So they think about these models and think about these representations, but we haven't yet engineered an infrastructure that will support that kind of microcognitive alternation in real-life tasks. So let's get to that, okay? So let's move from the single agent to the multiple agent, okay? So now we have the logical view on the left, the social view on the right. In the logical view, we're basically looking at an unpacked plan tree. So Marcia's at the top. She owns the top level action, which is deal with the notice. Do something about the notice. She starts to unpack that. Okay, I'm going to clean up the garden, okay, and then I'm going to deal with the city afterwards, but first I got to clean up the garden. Second note there is unlabeled. But as part of cleaning up the garden, she's going to get the gardener to do that, and then she's also going to get her mom to be at home so that she can meet the gardener. So now she's got the gardener involved and she's got her mom involved. How does she coordinate with them? Well, today, how she would do that is through email messages and voicemails and what have you. We'll see the system that we're going to about to propose. I better speed up here a little bit because I'm going to run out of time. With more people, more plans, more plan nodes, more actions, et cetera, et cetera, et cetera, it quickly becomes unmanageable. It's very difficult to maintain synchronized intentional state across all of these different individuals using just independently generated point messages. I'm just going to assert that. If you want to quibble with that, we can talk about that later, but that's an assertion for now. The solution is infrastructural support for managing a network of interlocking plans. Okay? All information is not created equal. Okay, there's non-task information and there's task information, and within the task information there are things that I'll call control signals. Those are the things which are transactional in nature that designate a change in that synchronized state. So for example, completion of a task, handoff of a task from one person to another, adding a stakeholder who has visibility into the status of those tasks. Those are transactional things. Terry Winograd and Fernando Flores, about 30 years ago, built a system called Coordinator that tried to address those kinds of formal state transitions through speech act theory. It was sort of met a kind of cold response from the user community and from the human-computer interaction community, which sort of set that research back for about 30 years. But it's sort of time to revisit that style of thinking because it has to do with this kind of state synchronization. So the architecture that we're proposing is the following, and you'll see extensions in a few minutes. 3 parts: coordination engine, which manages the social activity graph, right, the social logical graph that I described earlier. A personal prompter, which we're proposing as a category of software that's different from your inbox. It has different characteristics and a different style of use. It's more like a traffic system rather than taking 1,000 vehicles and putting them out in the parking lot and say, go to your destination. It's a little bit more regulated than that. I'll describe that in a second. And a template library that holds encapsulated procedural knowledge the way Wikipedia holds general knowledge. So this is something which would be a general resource that people can use for different things. Let's go through those one at a time. The coordination engine. The social task graph is essentially that network of people and the tasks that they share. The little red indicates ownership, and the blue boxes are the tasks. The other lines just represent stakeholder relations where people can see what's going on. Okay, and have a comment stream. They have a communication channel with the people, but they don't have complete responsibility for that activity. And the task lifecycle is to be able to create, hand off, and so on. All of those represent modifications in that graph, right? I won't say too much about it, but there's also just-in-time call synchronization. So if you need to reach somebody synchronously, the protocols handle that as well and makes that seamless, just like when you get on an on-ramp of a highway. Okay, the prompter cycle, you can think of the prompter cycle as essentially soft-scheduled, opt-in, dynamic opt-in office hours is a way to think about it. So these prompter sessions are little control points, little synchronization points over the course of your day. They're not the actual performance of the task, but they are points at which you review a small subset of the items that require your attention that are queued up by the coordination engine, and you perform quick transactions, rapid response that helps move the ball downfield for other people who are depending on you and also helps you get updated and make choices and so on. So those sessions are very dense. I'll say more about that in a bit. But they come periodically, and the frequency and the timing of those are heavily influenced by the analytics that live in the coordination engine, because the coordination engine has the right privileged perch to see the topology of the network of activities that are in play so that it can make smart recommendations about when and how to have these prompter sessions. The template library I mentioned before is essentially encapsulated scripts or best practices, but those can come at different levels of sharing. You can have a personal workspace where you save your own recurrent routines. You can share them with your friends and family and co-workers, or you can submit them for curation in the Wikipedia of Universal Shared Procedural Knowledge. And those might come in different flavors for different application areas, such as for health, education, and so on, how to lose 10 pounds, how to complete your term project, how to manage your diabetes, how to help your mom move from one place to another. But the point about them is they're not just bullet points in a PDF, they're actually executable routines that deploy into the activity graph through the coordination engine and prompt all of the other associated individuals to help keep them synchronized around that shared best practice. So they're very lightweight workflows that are designed for use by anybody through this infrastructure. Okay, I won't say too much about this, but the user engagement model, I guess I just described it in words before. The idea is that there are these prompter sessions. These are not drawn to scale. The real work gets done in those intervals between the prompter sessions. The prompter sessions are really just to keep everybody on track. And those are, you get basically your phone vibrates at a time that you selected, and if you say go away, then you're off the hook. You don't need to respond, but if you do respond, then you'll be served up a set of items that require your attention. You perform these little transactions, and you get on with your life. So one of the effects is to tend to localize in time, dealing with a lot of these little somewhat transactional things in a highly stylized way, in a way that's designed to be streamlined and efficient, because they highlight those control signals that you need. And the communication model includes both synchronous and asynchronous. I won't go into this too much. The asynchronous part is just a shared comment stream that's associated with any task in the system. And the synchronous part are these just-in-time calls that are scheduled by the system. And you can move smoothly between one and the other. I'll show you that when I go through these. So the user experience when they're in a prompter session is very much what they would get in a task list, right, or a to-do manager. This is where the to-do protocol comes into it. The owner of the task is listed here. If you were the owner, there would be no Darryl Jones there. And at any point in time, you can add a task, you can add a call request, you can add a method, and so on. If you do that in context, that's essentially a spawn. So if I'm in the context of one task and I create another task, the system remembers that as a spawn task, and that's what creates this logical hierarchy. Okay. Inside of the task, you of course have your comment stream, you have your timeline, you can go review the spawn tasks, and you have your share tab, which when you're handing off a task and you want to see who are the other stakeholders, I invite you to take this task, do you accept, do you decline? So that's how the activity network gets rewired. These things are in common with any social task manager that you see out there. So any kind of Jira or Pivotal Tracker or Asana or any kind of task manager that lets you operate on a data structure where there's task sharing will include this level of functionality. What they won't have is the idea of this call synchronization, because call synchronization is based on a stronger model with temporal constraints. Because in order for me to be able to seamlessly request a call with somebody and have the system set that up, the system has to have some overview without scheduling. This is the point, without scheduling. And the way that it works is, when I request a call with you'll, in your next prompter session, we'll see, hey, Stan has requested a call about topic XYZ. That's literally 2 clicks to create that request, plus call, submit, right, if you do it in context. The person says, yeah, I'll take that call. The system then nudges our sessions into alignment through the recommender engine, but it does that in a stochastic way that allows a large number of calls to be simultaneously nudged into alignment, okay? And then if people are no-shows, that both affects the recommendation engine's recommendation, but it also affects which calls are completed in real time, okay? We'll see that in a second. And finally, methods look pretty much just like a little script or a checklist. So these are things that could be produced by any user, and they can be produced in the prompter because the prompter has an editor. So anybody can come and create a bunch of these and then save it. And then by filling in who the professor is and hitting the launch button, essentially those things get deployed into the activity graph, and those individuals get their little prompts and their little reminders. Thanks. Okay, and finally, the session selector, this is where the recommender engine does its work. Why is the 3 o'clock bar so wide? Because the system is telling the individual, that would be a good time for you to be in a prompter session. Why? All kinds of reasons. co-availability of people you're trying to reach in, in a just-in-time call. That's the point at which you would optimize the dependencies. There are people who are waiting on you for certain things, and you're waiting on other people for things. That might be a good time for you to show up. Just because we're trying to create a certain frequency based on an analysis of the complexity of the tasks that are in your backlog, you need to engage a certain number of times if you're going to, by your own historical performance, and meet the goals that you have, and so on. So that's the basic idea. That's the basic cycle of operation. And the extensions to that, and I'll show you how they fit together, the extensions of that are to allow integration with other systems. The first extension is the coordination API, and that basically allows third-party systems to interoperate with the activity graph, and by so doing, interoperate with anybody who's using a prompter. Okay? And the second is the agent SDK, and that allows embedded software agents to act as if they were humans in the sense that they obey the same protocols that humans obey. So let's take two examples of that really, really quickly. First example, custom integration. So here it's some third-party software with a custom interface that wants to interoperate with a general prompter user. This person could be using email, they could be using a to-do list, or they could be using some other special system that happens to have some kind of workflow functionality, or that generates a task of some kind. And they want to interoperate with other people who are using this infrastructure. So that software would then spawn a task. The task would get registered in the activity graph, and then anybody who's using a prompter who was a named stakeholder on that could interoperate with that, okay, mediated by that software. A more specialized case of that would be, an example would be electronic health records, where you actually have a firewall and HIPAA regulations and all kinds of other stuff, okay? In a circumstance like that, the integration is a little bit more complicated, but this also speaks to the enterprise case. So you have a health professional interface, the electronic health record system in a local database, but you also have a coordination cache that holds the actual data, the actual proprietary or data that needs to be secured or held private. And then what gets registered in the activity graph is a sort of a sanitized version of that, okay, a reference to encrypted data that lives on the other side of the firewall. So that when the authenticated user makes reference to that, there's a pass-through that happens because the reference link gets dereferenced and the data gets decrypted at the client, okay? So there's no compromise of that data anywhere along that path until it's delivered to the authenticated user. But you still get full interoperability. So if the health professional over here wants to generate a task for a non-medical provider or for a caregiver or for a family member or what have you, then it operates through the system and it goes both directions. Just final, those little sheath pepper shakers there are actually little software bots. And, but the point is that they can be embedded in the network along with human beings. And they may have a lot of capabilities. Maybe one of them is monitoring a blood pressure machine. Maybe another one is doing something else. But they speak the same protocol. And you can insert them into the network in various places. And people are actually experimenting with this now and looking at, like, in the healthcare arena for having them serve as bridges, for example, between two disparate activities where they're monitoring the comment stream on both activities and bring certain things to the attention of the other. So you can imagine specialized functions like that, or delegating something to an assistant bot and then being able to get reports and checking off things at your prompter sessions. So anyway, thank you. By writing to me at stan@branchtime.com. We have a very stealthy website up right now. We have various groups that are working on this, but we haven't actually launched the system yet, and we haven't made a big noise about it either. So, but you're free to contact me, and I'll let you know more about it.
Okay. So we're going to break for lunch in just 1 second, so you can chat with more folks.
Thank you.
Really appreciate your time again, Dr. Rosenschein. Thank you.